All right, in class 81, we're just kind of practicing Snell's law. I'm going to go through this class a little bit quicker than the last couple. All right, so we have a ray of light with a frequency of that many hertz traveling through this medium at that angle, or excuse me, and it refracts at an angle of 90 degrees. So that's an important thing to just note is that theta 2 is going to be 90 degrees. All right, calculate the wavelength of the light ray in air. So this normally wouldn't be part of the question, but since it gives you the frequency of this question, why not? So we have V equals F lambda. Well, it's in air, right? So we know that V is going to be 3 times 10 to the 8th meters per second. F is going to be 5.09 times 10 to the 14 hertz. And we are looking for the wavelength. Divide both sides by 5.09 times 10 to the 14. You should get a wavelength of about 5.89 times 10 to the negative 7 meters. Measure the angle of incidence. So make sure you're able to do that. Theta 1 there should measure about 49, 50 degrees or so, give or take a couple degrees. You shouldn't be getting 40 degrees. Okay, that would be the wrong angle. That would be the complement to that angle. So make sure you're able to measure that fairly accurately. All right, so we've established theta 1 is 49, theta 2 is 90 because it tells us that's the refracted angle. All right, N1 is our unknown because we're starting in medium X and going into air. So air is N2. All right, so here's the Snell's law calculation for it. We get an index of refraction for N1 of about 1.33. So for the next one here, very similar, but now the question's actually turned like 90 degrees. So now material 1 is on the left, material 2 is on the right. Instead of going from the bottom to the top, we're going from left to right. So in this case, theta 1 is going to be, let's see, 30 degrees. So I'm going to jot down my givens just so we have them here. So theta 1 is going to be 30 degrees, and N1 is going to be our unknown. We're going into air, so N2 is going to be 1. That's the index of refraction of air. And theta 2 is going to be our angle of refraction, 60 degrees. Again, make sure you're able to measure that 60 degrees on your own. Again, the angle with respect to the normal, not 30 degrees. Okay, that'd be the wrong one. Working through the math there, you should get an index of refraction of about 1.7. Again, make sure your calculator is in degrees mode. All right, looking at question number 3, light goes from lucite into another material. The angle of incidence is 32 degrees. The angle of refraction is 16 degrees. So I wrote down our givens all over there. N1 is 1.5 for lucite, theta 1 and theta 2, incident and refraction. So did the light bend toward or away from the normal? Hopefully you notice it bent toward the normal, right? Because it was 32 degrees now away, now it's only 16 degrees away. So this must be a low index to high index problem. Remember, if theta 1 is greater than theta 2, then N1 must be less than N2. Okay, it's kind of the reverse. And look back to the previous class where we spoke a bit about that. All right, so working through the math here, let me change so the colors match. All right, so N1 is going to be 1.5. Theta 1 is going to be 32 degrees. I don't need to put the units in now because they're already in the givens. N2 is going to be my unknown. It's a mystery material. Sine of theta 2 is going to be 16 degrees. All right, so 1.5 times the sine of 32. We have 0.795 equals that, and 2 times the sine of 16 degrees, 0.276. Divide both sides by 0.276, so let's see, we got a point divided by second answer. We should get about 2.88 equals N2. So we were right, N2 is greater than N1. So our prediction was right because we're going from low, lucite, to higher than 1.5. All right, looks like the light here is bending toward the normal, so this must be a low to high question as well. So obviously the index of refraction of the mystery material has to be greater than 1 because air is as low as it can get. So you have to physically measure these angles. So we measured theta 1 to be 32 and theta 2 to be 10. All right, and let's work from there. So N1 is 1, sine of 32 degrees. N2 is our unknown, sine of 10 degrees. All right. So sine 32 is going to be 0.53 N2, and then sine of 10, 0.174. So we have 0.53 divided by 0.174, and we have about 3.05. All right, so N2 is greater than N1, so we're good.